Greetings, everybody. Hey, this is lab number 4, moon phases. And this is different than what we've done so far. This is basically a computer simulation lab. So let's go ahead and dive in. And I'll show you what it's about. This is the welcome page to the Lunar Phase Lab itself online. And what you can see here is this is a small version of the actual simulator. I'll show you that more later. Now you only have to worry about the so-called main content. Do not, did I say not? Do not look at, mess with this, because I've given you your student guide specifically for you on your instructions page on the Canvas website. So ignore the student guide that's here. Instead, I want you to look carefully at the background pages. There they are, 1 through 6. We're going to be using the Lunar Phase Simulation demo or simulator, as well as this particular demo. Okay, everybody with me? Here we go. Now, this is one of the pages, one of the background information pages, just simply introducing phases of the moon. And you should look through it carefully. You need to know these names, of course, what a new moon is and what a full moon is and first quarter and so forth. And they define them here in terms of percent illumination. That's a good number. New moon, of course, we got 0 illumination. Full moon, of course, we got 100. And the first and third quarters, we have 50% and so forth. Also down here, where it's talking about waxing and waning. Waxing means the phase is getting bigger. It's moving toward full moon. And waning means we're after full moon moving towards new. The phase is getting smaller. A gibbous is when the moon is more than 50% illuminated, and a crescent is when it's less. Now this is background page 2. This is the one I suggest you print out and just keep with you by your side while you go through this lab, as this really has the essence of the lab right here, friends. And let's take a quick look at it. Those of you that are in the lecture classes have already seen this, but it's good to review it, because this is really what this lab is all about, understanding what this particular thing is trying to show us. Over here on the left, we got sunlight. It's coming in, the sun's far away, so the rays are coming in basically parallel. Here's the Earth, here's the moon in various positions in its orbit around the Earth. Here at position 1, the thing to remember, of course, is that half the sun will be illuminated at all times, and the other half will not, okay? And notice the exact circumstances are the same everywhere. So the reason we have phases is because, are you ready? Have you got your pencil ready? The angle between the sun, Earth, and the moon changes during the month. So the sun, Earth, moon angle is what determines the phase. Wow, boy, I just gave away the essence of the lab, which is my job to do that. Notice that here, when we have sun, Earth, moon, 0 angle, we're looking only at the dark side of the moon, side that's unilluminated, and so we see that. Over here at position 3, notice we have a new sun, Earth, moon angle, sun, Earth, moon, got it, 90 degrees. And this is called first quarter. We're seeing half of the illuminated portion of the moon, and the other half we don't see. So it looks like that, a half moon. Over here at position 5, sun, Earth, moon, 180 degree angle. Notice we're seeing only the illuminated side of the moon. We don't see the unilluminated side. So that's called full moon for obvious reasons. By the way, 4 and 6 are gibbous phases. 4 is a waxing gibbous. That means that the gibbous is getting bigger. It's moving towards full moon. This is a waning gibbous, which means it's getting smaller and moving toward third quarter, which is what this one is here. And then a week after, remember this takes 4 weeks to go around. A week after position 7 at the third quarter, we're back here at noon. Now, I went through that kind of fast, but you can go look at it and carefully make sure you understand it. Like I said, this thing will really help you, and the lab will really help you understand this, and this will help you understand the lab. So use this thing. Here's another. This is another page just talking about rising and setting. I don't think we're doing much with this, but I thought I'd throw it in here anyway. Here's the actual horizon plane, if you've ever wondered how that relates to the Earth. And of course, the Earth is spinning. This is looking down at the North Pole. The Earth is spinning around counterclockwise, and so forth and so on. Check it out. Now, here's what the actual lunar phase simulator looks like. This is what it actually looks like. You can configure it any number of ways, by the way. And I've done it one particular way that I like. And actually, one of the questions you're going to be asked asks you to do it this way too. Notice here it says show angle. The angle they're talking about is the secret angle, friends, the one I just told you about. That is the Sun-Earth-Moon angle. That is what determines, you guessed it, the phases of the moon. But this thing is showing you the Sun-Earth-Moon circumstances, the actual phase of the moon, and what it looks like from the horizon, including the sun and the moon in the sky and the observers at the center. All three of these things are synced. You change one thing in one portion of it, it ripples through the others. Very nice. Now, a nice way to get used to this might be when you first come in, see where it says start animation? You might do a very slow version of this because fast versions you can't keep track of. But do a slow version of the animation. Actually watch the moon go through a few cycles. Watch how the phase changes. Watch how the moon and the sun go through the sky relative to an observer at the center of the horizon. That sort of thing. This is a fun little gadget. And by the way, you can adjust the phase of the moon, and guess what will happen? The Sun-Earth-Moon angle will change accordingly. Boy, you have, folks, let's be honest, you have godlike powers with this simulation. You may not want to quit after we're done. Here's the phase, time, and horizon thing. This is sort of showing you how all these things exist, how they all are coordinated here. This is just showing you, again, the phase. That's a first quarter moon. Now, here's one thing you need to realize. Time, when somebody tells you the time, they are telling you the position of the sun in the sky, okay? If the sun is rising in the east, that's 6 a.m. We don't deal with seasonal changes here, so everything is taken to be consistent. 6 p.m. is when the sun sets. When the sun is overhead or on the celestial meridian, and the celestial meridian is a line that goes from straight north to straight south through the sky and divides the sky exactly in one half. Make a note of that, central meridian. So when the sun crosses the meridian, that's taken as noon. And here again is the observer's horizon, and if the moon is here, this guy won't be able to see it. You might be amused by reading through that and seeing how somebody apparently fibbed in a crime investigation saying they saw the first quarter moon at such and such 3 a.m. in the sky, and that's demonstrably false. Oh, here's the fun little hints, or the fun little things that you can do on your way to working with the lunar phase simulator, the LPS. This just tells you all the things you can do. You can drag, it says the observer's horizon diagram can be dragged to allow for the most conventional viewing, most convenient viewing. The moon phase panel shows the current moon phase and so forth. It just gives you hints as to everything you can do with this. And you should play with it a little bit and see how much fun it is. This is the beginning of the student guide. This is the thing you're going to be printing out. Make sure you print out the right one. Print out the one that's in your instructions in the Canvas homepage. Don't print out the one on the website because that won't be as much fun for you. Anyway, this is the one that, this is actually the first page. And notice what it says. It says, answer the following questions after reviewing the background pages for the simulator. So don't go into these until you've actually looked at those. This gets into the dark side of the moon thing that we've already talked about. The answer is there is, because the moon is spinning or rotating. Oh, I noticed that some people, I don't know if it's any of you folks, but some people insist on using the word rotate to mean orbit. Rotate means when a planet spins on an axis. Okay, the Earth rotates at 24 hours, but it orbits at 365 days. So try not to get those confused. Since the moon is rotating and spinning, it spins once per month, just like it orbits once per month. Okay, that's not really important to the phases, but it results in one side of the moon always facing the Earth. It's not a coincidence. It's a matter of tidal forces degrading, slowing down the rotation, that is the spinning of the moon. Anyway, yeah, how long does it take the moon to complete one cycle? You can check that out. If the moon is full today, what phase do you expect to be in a week? Well, it'll be full plus 1 week, which is the third quarter. Now here's the moon bisector. This is just simply, I'm going to actually talk about this for 2 seconds. It's saying draw the line perpendicular to the sunlight. Well, here's the sunlight line. So a perpendicular line would be like that. You guys all watching? And draw a line perpendicular to the Earth-Moon line. Here's the Earth-Moon line. So perpendicular to that would be like that. And if I were you and you actually draw this on this diagram, get the thinnest pen you've got, and then you'll be able to see these relationships. I just showed you how to draw those. It's not difficult. Then what they want you to do is figure out what portion you can actually see that is not shadowed from the Earth, and then estimate the phase down here. It's a fun little exercise. And here's the best one of all. Here's the phase exercise. This is the one that you'll do with the lunar phase simulator, and you'll adjust it for all of these conditions. Each one of these rows is a new set of conditions. Now, what I suggested in the instructions is a good idea. After you print this thing out, you are going to be, I can't really show you, but this is not the sheet, but you're going to be able to rotate the sheet in such a way that the sunlight is always on the left side. In other words, take this one and rotate it so the sunlight is over here. Take this one and rotate it so it's over here. Why would you want to do that? Because that'll make it just like the lunar phase simulator, which always has the sun coming from the left, and all of a sudden everything looks a lot easier. I don't think you'll have any trouble with these if you do that little trick. Here's the times. This is the last, but the instructions here are explicit. Here's another little hint. When the time between rising and setting is always going to be what? 12 hours, okay? And the rising will be 6 hours before the meridian crossing, and the meridian crossing will be 6 hours before setting. Geez, I just gave away the whole table. But check and make sure those things are really happening. Here they've actually given you one to start with. But you can use the lunar planetary or the lunar phase simulator to figure this out, and the instructions are explicit. I don't think I'll have any trouble with that. Let's see. I think that's all I have to say. That what you should do first, after you've watched this video, is go read the instruction page on this lab on the Canvas homepage, okay?